Right. Good afternoon, everybody, and welcome to this webinar on Spring LDAP 2.0. My name is Mattias Arthursson. I'm a software developer, software architect. I've been doing that for like 20 years or so. I'm currently running my own consultancy, 261 Consulting, out of Sweden. Now, I've been involved in the Spring LDAP project for since the very beginning, actually. My colleague Ulrich Sandberg and I founded it way back, and this last spring I got the opportunity to do some additional work on the 2.0 version of Spring LDAP, sponsored by Pivotal. So, on the agenda for today, we'll start off with doing a real quick flyby of the basic concepts of LDAP, basically. We'll move on to defining why we need Spring LDAP and looking at the new features in 2.0, comparing them to the old features in 1.x. Then we'll move on to the details, the configuration and the core API, a really cool feature, the object directory mapping, and finally the Spring Data repository support for LDAP as well. Right, so in my experience, LDAP is kind of an old, obscure technology. Many people don't really have any hands-on experience with it. So usually it's a good idea to just run through the basics so that everyone is on the same page. So I'll do this real quick, so please just bear with me through this short LDAP introduction. The core concepts of LDAP. So LDAP stands for Lightweight Directory Access Protocol. So it's actually a protocol. Normally, it's backed by some kind of database, an LDAP database. That would be, for instance, OpenLDAP for Linux and Unix systems. Obviously, on Microsoft systems, you have Active Directory. And the one defining aspects of an LDAP database is that the data is organized in a tree structure. So obviously, when it's a tree structure, the obvious way of finding an entry would be to traverse the tree down to the node that you find. So the unique identifier of an entry in the LDAP tree is defined by the tree path, and that's called the distinguished name. And that's something that you'll hear a lot throughout this talk. An interesting characteristic of the distinguished name is that the least significant component is first. So when traversing the tree, you actually read it backwards, so from right to left. So once we find our entry in the LDAP tree, there's some data bound to the entry. And the data that we bind to an entry is called attributes. So any entry in the tree can have a number of different attributes. Each attribute can be single or multi-value. And the valid attribute for an entry is defined by the object class that we define for that entry. So we'll look closer at some examples of that later on. As I said, the unique identifier of an entry in the LDAP tree is the distinguished name, the tree path. So if we have the distinguished name, we can directly look up the entry in the tree. But if you want to do a broader search based on some characteristic or some condition, we need to do that using LDAP filters. So that's what we use when we search for data rather than look them up. A very simple example of an LDAP tree. This is pretty shallow, but obviously they can be of arbitrary depth or height, but it's actually quite common for LDAP trees to be quite shallow. So in this case, we have the top node here. That's the domain controller node or the root node of this LDAP server. The DC equals example, DC equals com. We have two organizational units here. We have the people and the groups node. The people node, obviously, it groups the users in the system. We have two users here, John Doe and Jane Doe. And we have the groups node, which contains all of the groups in this LDAP system. Looking at this tree, we can traverse the tree down from the top to the bottom right, left corner. DC equals example, DC equals com, OU equals people. UID equals John Doe, and that would result in the display distinguished name here. So this is the unique identifier of that node. Since this is a user in the system, we've defined a number of different object classes on this entry. All of these object classes has to do with persons and define their own attributes that you can then assign to this entry. So for instance, we have the UID, we have an employee number, a given name, and so on and so forth. We also have a couple of more obscure ones like CN on SN. The CN is a very common attribute. That's the common name of an entry. That is the full name of the entry. SN, in this case, is the surname of the user. It's important to note that the names of these attributes are strictly defined by the attribute definitions in the object class. So you can't decide what you want to call your attributes unless you create your own and create your own object classes. That's typically something that you don't do very often. So displayed here is a subset of what the information that you can define on a user. There are many more attributes available. Once again, those are defined by the object classes. So looking more closely at group node, this is the users node. We have the distinguished name at the top there. A group is typically of one of two different object classes. This one is a group of names. The other one is usually is called a group of unique names. And you would usually define two attributes for a group node. That's a CN, once again, the common name of the group, and the member attribute. The group of names has a member attribute. The group of unique names has a unique member attribute. And the member attribute, obviously, that contains the members of this group. So they are identified by their distinguished name. So in this case, we have the John Doe and the Jane Doe user. They're both members of the attribute, this user group. So the member is a multi-value attribute where you define the members of the group. Once again, if you have the distinguished name, you can look the entry up directly in the tree. But if you want to search, if you have some condition that you want to find users, you would need to use an LDAP filter. And so in this case, we're looking for users whose name contains the string Doe, and that would be the displayed LDAP filter here. So you can see that the LDAP filters will very quickly become very complicated. They're hard to read, and they're actually pretty hard to manually build as well. So we have some pretty cool features to help you do that in Spring LDAP. Right, so that's a real quick flyby of LDAP. Next up is, why do we need Spring LDAP? Well, the basic goal of Spring LDAP is to make Java LDAP programming as simple as possible, because Java LDAP programming is not simple, and it's not fun either. It's dull and it's very verbose. It's very similar to JDBC in many ways. Particularly, there's a lot of plumbing code that you need to repeat over and over again. And you have to repeat code over and over again. It's very, very easy to make mistakes, subtle mistakes that just you introduce in some of those places, which means that it gets very, very error prone. And so we have the repeating structure. For very simple tasks, we need to do the same thing over and over again. So the general flow is you open a connection, you perform a query, you get some kind of result back, you loop through that data, you extract the stuff that you want, and then you need to close the connection and handle all the checked exceptions. That will happen throughout different stages of these operations. Very, very important to clean up. As everyone knows, if you forget to clean up, you will get a connection leak, and eventually you'll get angry phone calls from system admins. So All of this is something that you need to do over and over again if you do plain Java LDAP programming. Actually, this is even worse than JDBC because the connection management in Java LDAP programming is more obscure than the one in JDBC. And also, as I said before, filter syntax is fairly complicated, and that combined with the fact that many people doesn't really have an extensive experience with LDAP calls for some way of making LDAP programming easier. So Spring JDBC is obviously very much inspired by Spring LDAP is very, very inspired by Spring JDBC. So we have our template, the LDAP template that handles the common flow, the boilerplate code that needs to take place all over and over again. And we leave the details to callback interfaces and some support classes. So on top of the LDAP template, there's also some useful abstractions to work with different aspects of LDAP programming, such as distinguished name construction and manipulation, and filter construction as well. So all in all, this just fits pretty well into the general Spring picture. Focus the code on what is important, and leave the details that you don't want to worry about to the framework. So that's pretty much it. Just one final note: what Spring LDAP is intended to be used for administering LDAP data. It is not intended to be used for authentication or authorization purposes, which is kind of strange because that's what you usually want to use LDAP for. What you should use for doing that is Spring Security, because Spring Security takes a much broader view on the whole security aspect. So the LDAP support in Spring Security does build on Spring LDAP, so indirectly you will be using Spring LDAP anyway. But unless you have a very, very simple use case, I would advise against using the very simple authentication methods that is included in LDAP template. So use Spring Security. That's the general advice. Now, just as an illustration, why we need to do something about this. This is a real-world example of getting the names of all the users in a system. So you can see there's lots and lots of plumbing code in there. The interesting parts, the ones that's really specific for this use case, is highlighted in bold. And so you can see that most of this is actually just unnecessary stuff. And just as an illustration, without going into details here, this is how you would do the exact same thing in Spring LDAP. So you define a query, and then you implement a callback interface specifying what you want to get back from each entry. And LDAP template will add that to a list and return it for you. Right, so now that we know that we need Spring LDAP, so what's in there? First of all, in Spring LDAP 1.x, there was quite a bit in there. Most of that was centered around the LDAP template, along with the callback interfaces. It was all Java 1.4, so there were no generics and var args in there. There was a submodule called Spring LDAP Tiger that had a simple LDAP template with generics at least. But otherwise it was mostly the LDAP template, along with some utilities for filter abstractions, the dual context adapter for helping out with extracting and modifying attributes. And also we had distinguished name implementation, because Java 1.4 doesn't have an official LDAP name class or a distinguished name implementation. So aside from those, we have a pretty cool pooling support, which is actually needed because the built-in or native Java pooling support for LDAP really doesn't meet the requirements that you would need to have fulfilled. So if you need to have connection pooling against an LDAP database, you should definitely look into the pooling support in Spring LDAP. Also, we have the object directory mapping. That was also a separate module in Spring LDAP 1.x, providing automatic mapping to and from domain objects using Spring LDAP. And another pretty cool feature that we have is compensating transactions for LDAP. As you might know, LDAP doesn't have any native transactions, so this is all client-side, but it could be pretty useful in some cases. It's all client-side, it's all compensating transactions, but it could be useful in some cases. Right, so version 2.0, we've upped the Java version to 1.6. So we have generics and varargs in the core APIs everywhere, and as a consequence of that, the Spring LDAP Tiger module is deprecated. We are using a number of API calls that's in 1.6, so 1.5 won't work. So you need to make sure that you're running 1.6 if you want to upgrade to version 2.0 of Spring LDAP. Another major thing that we did was that we moved the object directory mapping feature to the core module, which means that Spring LDAP ODM, the old module for that, is now deprecated. It's still in there, but as with Spring LDAP Tiger, those are both deprecated, and if you're using them, you're encouraged to use the new APIs instead. Just migrate to the new APIs, is the general advice for that. So LDAP template now recognizes and handles ODM annotated classes. We'll look more closely at that later on. In 2.0, we also included a new XML namespace. We didn't have that before for simplifying configuration. We have a pretty cool Fluent builder support for building LDAP queries. Aligning with Spring Data, we have full support for Spring Data repositories against an LDAP data source. We have QueryDSL support, and we did a major overhaul of the samples. The samples before were pretty useless, but we put quite a bit of work into that. In particular, there's a very good sample that is user and group administration application. That's basically something that you can build on for doing a real-world application for doing that in LDAP. So make sure you check out the samples. There's the link there at the bottom. It's on GitHub. Another major point to note here is that the distinguished name is now, the distinguished name class in Spring LDAP is now deprecated. Since in Java 1.5 and higher, there is a pretty good distinguished name implementation in Java core called LDAP name. So distinguished name, if you're using that, you should migrate away from that as well. Right, so moving on to the details. Configuration and core components. Since I've said before, LDAP connection management in Java is actually quite complicated. There's no abstraction that we have like the JDBC data source, so we introduced that in Spring LDAP. It's called context source. It all handles the configuration of the connection management and the creation and the creation of and authentication of connections against an LDAP data source. So the context source is created, and then you supply that to the LDAP template, which is where all the magic happens, basically. It encapsulates all the boilerplate exactly like a JDBC template. It leaves the details to the callback interfaces that you supply. And there's lots and lots of overloaded methods in there. So the general idea is that anything that you are available to do in plain Java LDAP programming, you should be able to do that using LDAP template as well. But when you're using it, just make sure that you use the simplest possible method signature you can find, because there's many ways to do the same thing, just as with JDBC template. Right, so configuration. What you do basically is that you include the new LDAP namespace definition, the same way that you would include another namespace definition. You configure the core components, and then you just use dependency injection, just as usual, injecting the LDAP template into your repository. So let's have a quick look at how that would look in real life. A very simple configuration file here. We included the LDAP namespace here, and that enables us to use the LDAP-specific elements here. So what we define here is one context source and one LDAP template. On the context source, we need to define the properties that it should use when connecting to the LDAP server. So we need a username, we need a password, and we need a URL. The username is typically, that will be the distinguished name of the admin user that you want to use for connecting to the LDAP server. But that depends on the actual server that you're working against. For some users, that would be, for some servers, that would be the UID of the admin user. But the general way it is that it's the distinguished name of the admin user. So password, nothing special with that. And the URL, basically the LDAP URL to the server that we want to work against. It's interesting to note here that if you have several LDAP servers and you want to use failover, in case one of them goes down, you can define multiple LDAP URLs here. Like this. But we won't be doing that today. That's for very special cases. So that's the attributes that are actually required. In addition to this, it's very common to define a base node in the tree that all of the operations should be relative to. So, for instance, if we go back to the LDAP tree, the example we saw before, at the very top there was the domain controller node. And everything is relative to that in a way, so we might as well just start there from the very beginning. So we don't need to include the domain controller components in all of our URL or all of our distinguished names that we construct in our application. So it's very common to include the base URL there. We can have a look at how that looks in our application. In this case, it is the domain controller node. So when we work with connections that come from this context source, everything will be relative to that domain controller node. Then we just define an LDAP template that will automatically be injected with the context source that we created here. So there's nothing more to it. After that, you have your repository, you use dependency injection and AutoWire to have that injected into your repository, just as normal. Quick note here, there's more stuff that you can define on your context source. If you want to use the pooling, this is where you do it. You define a sub-element to the context source, and you can then define the different characteristics of the pooling that you want to use. Typically, you would want to define how many active, how many maximum connections you can have. You would want to define whether to test when you're getting a new connection or returning it, if you want to test when you're idle, and so on and so forth, and the validation query. So that's something that you would typically want to configure as well. Right, so that's the configuration. Closer look at the main callback interfaces and support classes. When extracting data from searches and lookups, you would use an attributes mapper or a context mapper. The attributes mapper will work against the JNDI attributes class, which is kind of awkward. So to simplify that, you can use the context mapper instead, which will give you a dir context adapter, which makes it much easier to extract and modify attributes than the attributes mapper. So that's generally what you want to use. Then, as I said before, to be able to efficiently build queries against an LDAP tree, you can use the Fluent builder for LDAP queries, which is the LDAP query builder. Basically, the goal of that is that you shouldn't need to know anything about search filters to be able to use that. All you need to know is the attribute names and the conditions that you want to use. So we'll look more closely at that later on. And then for working with distinguished names, as I said before, there's an LDAP name class in Java 1.5 and higher, which is pretty good. It's RFC compliant and everything, but it has its own deficiencies. So we have a number of utilities there for working with distinguished names. We'll take a closer look at them later on. So as I said, we have the LDAP name class. It has a couple of deficiencies. First of all, it's mutable. And since we're using this for identifying entries in the LDAP tree, it's really not a good idea to have those mutable. We would at least like to pretend that they're not mutable. So that's why we supply a couple of utilities for working with them. So the mutability is one thing. And the other thing is that the LDAP name throws checked exceptions everywhere. And that can be a real pain to work with. You need to take them into account everywhere. And so the utilities help you with that as well. So we have the LDAP name builder to help building LDAP names. And there's also a couple of methods in LDAP utils that help you work with distinguished names. So let's have a look at what that looks like in real code. We can use the LDAP utils new LDAP name with the distinguished name, and that will create an LDAP name for you. This doesn't really do much except that it removes the checked exception. So if you would do this in plain LDAP code, this would throw an exception that you need to take into account, and it's just a pain. So we've created an LDAP name, and then we can use that as a starting point and input to the LDAP name builder if we want to build new LDAP names that originate at this node. So in this case, we start off with the people node, and we add UID equals John Doe, and we build that. So that would then result in a distinguished name looking like this. Let's just comment this out for a little while and try to run this. So nothing special there. Once again, just makes it easier to work with distinguished names where you want. Another really cool feature is that you can extract data from this distinguished name. So for instance, looking at this one, if we want to have the value of the UID component, so we want to extract John Doe from this, we could do this with splitting up the string and looking for equality signs and stuff like that, but that's really nothing that you want to do. So you can use LDAP util.getStringValue to do that. So you supply name instance to that method, and you specify the attribute name that you want to extract, and that will do that for you. So if we try to run this, we would expect to get John.Doe back. Yes. So there's more in here. There's stuff for concatenating LDAP names and stuff like that as well. But this is pretty much the main utilities there. So that's the distinguished names. moving on to LDAP queries. Once again, constructing LDAP filters is kind of hard. It's the syntax is kind of difficult. It gets very complicated very fast, and you also want to avoid manually constructing LDAP filters, particularly if you're including user input, because the same way that you have the same problem in JDBC, if you would be concatenating together a SQL query, if you include user input in that, you would enable SQL injection. The same thing applies to LDAP. So if you're using user input when you build your LDAP filters, you could actually enable LDAP injection into your queries. So you want to avoid that. So what you should do is that you should use the LDAP query builder. So that's a Fluent API for specifying everything that you need to specify when you execute an LDAP search. So you specify the basic search configuration, which is the base path, meaning the node in the LDAP tree where the search should originate. You specify the search scope. You can specify timeouts. You can specify the attributes to return, stuff like that. And then you append filter conditions using a Fluent API. So you can use this with the object directory mapping, or you can use it with the core interfaces. So let's take a quick look at how that would look. In this test, we are launching an in-memory Apache directory service server that's initialized with a couple of users corresponding to the tree that we saw before. So let's try that out. What we would do now, we have an LDAP template, so we do LDAP template.search, and we specify query dot, let's specify a base starting at the OU equals people node, and then append the search criteria. So now we'd like to look for entries that have the object class person. So we do it like this, where object class dot is. So that's the actual search criteria, and now we need some way of mapping the data that comes back, and we'll do that with an attributes mapper. Basically, in this case, just return the common name. And we'll get that back as a list. Let's just write that out and verify that it works. So we expect to get the common names of both the users that we have in our system. And yes, that's John Doe and it's Jane Doe. So if we would like to add some more search conditions here, we can just append them like this. And let's look for the John node specifically, where given name is John. So now we would expect to get one user back because we added another condition here. And yes, there it is. We have John Doe found from this condition. So you can go on appending more conditions here. There's different comparisons you can use. You can use greater than or less than. You can do like, which is basically a wildcard search. So if we would do like John star, that would return everyone whose name starts with John, and so on and so forth. So you can play around with that. But that's pretty much all I have to say about that right now. Moving on to the really cool parts, the object directory mapping. We've been used to do this with relational databases using JPA and Hibernate, and Spring Data has that for several different data stores. We got the MongoDB and Neo4j and all of that. So we used to just declaratively annotate our classes using specific annotations, and then have the framework mapped to and from our domain objects based on that. So basically, it's just a more modern approach to this. So this is actually, that was included in Spring LDAP 1.x, but it's now moved into the core of Spring LDAP. So the annotations that you need to use, first of all, you need to annotate your class with @entry. That marks this class as a managed class of ODM. And the entry annotation, in that you would define the object classes of the entry, and you would also include an optional base LDAP path where these entries are located in the LDAP tree. Then you need to have an ID field, which marks a field that is the unique identifier of this entry. So that needs to be of type javax.naming.name. And then you just annotate the other fields of your class with @attribute. Marks it as a field that should be mapped to and from the LDAP entries in the tree. You can optionally define an attribute name in there. Otherwise, that would default to the field name. Finally, the @dn attribute. If you want ODM to automatically build distinguished names of your entries, or if you want to extract stuff from the distinguished name and be able to access that from your entity class, you can annotate your class, your attribute or your field with @dn attribute. You specify the dn component name and the index for that. So, for instance, going back to our initial LDAP tree in the example, if that would have been deeper, so for instance, if we would have been organizing our users in departments, that would typically be a new level in the tree. In order to get the value of the department out, you can use the @dn attribute annotation to get that included in the distinguished name and extracted from the distinguished name when the data is read from the database. Right, so in the newest version, LDAP template has a number of new methods that will recognize annotated classes. So if they have the @entry annotation, you can use any of these different methods to read and modify data in the backing store based on the annotations. So let's have a quick look at what that might look like. First of all, we'll have a look at an annotated class. So we have a user class here. It's annotated with @entry. We specify the object classes that this entry is supposed to be having. And we also define where in the LDAP tree these entries should have its parent, right? So we also define an ID field, which is of type javax.naming.name, and we have a couple of different attributes here. So in this case, the CN attributes, we map that to the field full name, given name, and map that to the first name property. And the UID, we map that to the UID property. And you can note here as well that we included the @dn attribute annotation, which makes it possible for ODM to automatically create the distinguished names of new entries and updated entries of this class. So if we go back to using that, so we create a new test. we can use LDAP template.findAll to specify the user class, and this should return all users back to us. We'll just print them out here to verify that it works. So we'll run the application again, or the test here again. And that should give us 2 entries back, right? And yes, we have the John Doe user, and to the right here, we have the Jane Doe user. And all of the attributes that we defined have been properly mapped to the entries. And obviously, you can make sure you can use the same query, the same query notation that you did before. If you want to use, once again, if we want to find the John user again, so we can do query where and for that we need to use the find method, and in this case we should just get 1 back. So waiting for this to start again, and yes, we just get 1 entry back. So, and we can also, if we want to modify data, we can use the find one method. That will just return 1 entry. And we can now just user.set first name, we'll modify that, and we can use that as input to LDAP template.update. And that will automatically calculate the optimal attribute modifications based on what we have done to this entry. So that's basically the ODM features. There's much more in there, but this is the basics of that, at least. Right, so saving the coolest thing for last, the repository support. Spring Data has this. Spring Data Commons has a very, very good starting point for doing this. So we integrated with that, and together with the object directory mapping feature, Spring LDAP now has full repository support, as in is expected from Spring Data projects, basically. So that enables you to create LDAP repositories basically without a single line of code. So all you need to do is you annotate your entity classes, as you saw before. You extend LDAP repository. You create a new interface extending LDAP repository interface. You may, if you want, you can define additional finders there. And then finally, you instruct in your configuration, you instruct the framework to scan for repositories, and then the repository implementation will be automatically generated for you. So the LDAP repository is based on the Spring Data CRUD repository. So it has the same methods that you would expect a CRUD repository to have. Save, find one, exists, all of that. And it also has a couple of LDAP-specific methods as well. So if you want to execute queries and get mapped domain objects back, you can use the find one and find all with an LDAP query as an input. Please note that the save method here, it will automatically calculate whether this is a new entry or an existing entry. So if the entry already exists, it will try to update it, and if it's a new one, it will try to create it. So that means that if you want to update something, you should typically have retrieved that first using, for example, find one with the distinguished name or one of the LDAP-specific methods down here. So otherwise it will be very hard to calculate whether it's a new or an existing entry. So a demo of the repository support. Let's go ahead first to create a user repo. That should be an interface. We'll get a user repo. That should extend ldap-repository. And we specify the domain object type here. And that's everything we need to do in this repository. This will be sufficient for generating repository for us. But we need to instruct the framework to scan for repositories as well. So we do ldap.repositories, specify the base package where our repositories are located. And in this case, that would be com.example.domain. And now the repository is ready to use. So we can use that in our test. We can make sure that will be injected for us. And then we can create a new test where we use that user repo. So we do user repo dot find all, for instance. And just verify that that does the correct thing. Running that should return 2 users. And yes, we do get 2 users back. So let's see if we can do the same thing here. We find one. We steal the query from up here. Let's get the John Doe node back. And that will return that should be it, shouldn't it? Yes, that was the IDE that was messing with us. So now we get 1 user back. We can update that. And then we can just do user repo dot save with the 1 user. And then just to verify that everything is all right, we can no, this is correct, isn't it? Let's just see if we can do that. See if that works. No. Oh, that's a shame. Can't get that to work. Well, anyway, this is supposed to be working, but given the short time frame here, I can't really get it to work. Sorry about that. You should be able to get one up. It takes an LDAP query. That's an LDAP query. No. Sorry about that. Anyway, this should work. You should be able to get 1 user out. You set the first name, you save that one, and then you this will automatically be updated in your in the backing store. So that's the basic repository support. Then there's the support for automatically generated finders. So if you want to have finders generated for you for some specific condition, you can define additional methods in your interface, and based on the names of those methods, a search filter will automatically be generated for you. So you can do that automatically based on the method name, or you can do it explicitly using the @query annotation. So let's just have a look at what that might look like. In our user repo, let's see if we can get user find by first name. That should be sufficient. That maps against the field name in your annotated class. So this should find a unique user using the supplied first name. So we should be able to use that in our class. So this is basically what we're trying to do before. We'll get John back, and we print him out. Yes, and that's John back, and so we can now do what I was trying to do before. We can user.set first name, and we can use that as an input to oh no, I'm not using the repository here. Sorry about that. We should have been using the repository here. I'm confused. I'm in the wrong place. Sorry about the confusion. I'll just get rid of this. User.set first name, John.set first name. And then we can do user repo.save. So that should work for us. Right, so that's when you want to have your queries automatically generated for you. If you want to be explicit, you can do query, use the query annotation, and that's where you specify an explicit search filter here. So we do given name equals 0, and so this will automatically generate a filter that it will include the first name from the query and put that in here. And as I said before, you usually want to avoid to do specific or explicitly build LDAP filters yourself, but in some cases it will be necessary, and this will do that for you. So basically that's everything I have for the repository support here. We're running out of time here, so the deal context adapter will have to wait for another time. And it's time to wrap up, basically. So my closing words here, please make sure to check out the samples because they are pretty good now. If there are any details of the framework that you need more information on, please check out the project homepage at project.spring.io. There's a quite extensive reference documentation. Obviously, all of the code is public on GitHub. If you find something that doesn't seem to be working correctly, you can go to jira.spring.io and file a Jira issue there. Please do that if you find something that seems not to be working correctly, or if you have a new feature request. You can get more information about things that happened with Spring LDAP by following Spring LDAP on Twitter. This video will be published on YouTube later on, so make sure to check out that. There's many more videos there on Spring subjects. And there's obviously the LinkedIn and the Google Plus as well. If you have any more questions or you need more specific help, I am running my own consultancy, so check that out. Or feel free to message me on Twitter. My Twitter handle is @Arthursson. And with that, I would like to thank you for the attention and leave it open for questions. Thank you.
Hi, Mattias. This is Rob here, and I just wanted to say thank you again for your presentation. We did have a few questions. I was answering most of them throughout the presentation, but one of the questions is, how are referrals handled in Active Directory?
Right, referrals, that's a very interesting question. What will happen normally when you execute an LDAP query is that you will have to, if you perform a search like this and you encounter a referral, you will typically get a referral exception that should be handled. There's really no way for you to handle that in your code. So what you need to do is actually you need to handle that using configuration. So what you do here is in the context source, when you configure that, you specify referral, and you specify that you want to follow referrals. And also, for some cases, if it's not possible to follow referrals, because sometimes referrals are actually returned with invalid values. That's quite common actually for Active Directory. In that case, you will configure your LDAP template and say that you want to ignore partial result exceptions. You set that to true. So there's basically two ways of doing this. One, if you think you will be encountering referrals that are valid, specify referral equals follow on your context source element. If you want to ignore referral exceptions, specify ignore partial results on your LDAP template. There is more information about this in the reference documentation as well.
Great, thank you. I'll go ahead and go over some of our housekeeping while we wait for some more questions to appear. These videos will be posted to spring.io/video and the Spring.io blog within the next 2 weeks. We try to get it out sooner, but we usually give ourselves 2 weeks to do so. And we recommend that you subscribe to the Spring.io video or the Atom feed on the Spring.io blog to get notifications when these new postings occur. I'd also like to invite you guys to join us on Tuesday, March 25th for a webinar on Spring Framework 4.0 and Java 8 with none other than Jürgen Haller. And you can register for that on the Spring.io. I'll go ahead and send out a message to everyone so you can actually follow the link if you'd like. And I'd also like to mention that you can give us feedback at Spring Central on Twitter. It looks like we do have a few more questions. Let's see if we can get to those. It's a little vague. Spring security integration with LDAP. If you'd like, I could go ahead and handle that one, Mattias.
Sure.
Might be more appropriate for me anyways. Mm-hmm. Regarding these updates. So Spring Security supports Spring LDAP 2.01. So you need to use Spring LDAP 2.01 and you need to use Spring Security 3.2.2. There was a bug found, but if you're using the latest of each of those, Spring LDAP 2 and Spring Security 3.2 will work together. So I hope that answers that question. And here's the link. I just responded to that question to everyone that has a link to register for the blog. And we have yet another question. Do we have any thoughts on handling nested groups in different directory servers?
Could you repeat that one, please?
Sure. Do we have any thoughts on handling nested groups in different directory servers?
That's a little bit vague. It's not a use case that I've encountered before, so I'm not really sure exactly what's meant by that question. So
they expanded on that, saying meaning Active Directory versus Open LDAP.
All right. So are you having, if you're having groups or users and groups in different directories, and you want to administer them in the same application? Is that the question, or?
We'll give them just a minute to respond here. We might go ahead and let them follow up with you on Twitter. It seems like they're either having issues with WebEx or they are unable to respond for some other reason. So we'll, if you're listening, go ahead and send out a tweet to Spring Central with your question, or to Mattias at Arthursson. You could also send it to Spring LDAP, and either one of those locations will get to Mattias properly. Once again, thank you for joining today's session, and we hope to see you next Tuesday for the Spring Framework 4.0 and Java 8 presentation. Thank you.